Today we're in your packet on day 4. We are doing applications of all of the SOHCAHTOA. So if you're still not 100% comfortable, we'll still be reviewing that in this lesson as well. The main two applications we look at are what we call angles of elevation and angles of depression. An angle of elevation is an angle formed with the horizontal line and then a line going and a line up. So for example, in this particular picture, if I'm standing at point A, you can see my horizontal line is here and I'm looking up. So this angle in here is called an angle of elevation. On the second one, again, it's an angle. It's still formed by with the horizontal, but in this case, you are looking down. So this particular case, if you're standing here, again, you're looking out and then you're looking down. This is called the angle of depression. And again, here you were looking out and up. That was the angle of elevation. One thing you might notice is with these angles of elevation and the angle of depression, these lines are horizontal. These angles are alternate interiors, so we also know that those angles are congruent. Looking at number 1, they want us just to identify angles of elevation and angles of depression. So let's go look at elevation to begin with. And again, what we said was that means you're looking straight out and then you are looking up. Let's start at angle 1. Angle 1, you're looking out and then you're looking down. So in this particular case, angle 1 is an angle of depression. If you look at angle 2, you're looking out and then you're looking up at the plane. That's an angle of elevation. Angle 3, you're looking out and looking down, so that's angle of depression. And 4, you're looking out and you're looking up, so that is elevation as well. So let's look really at a few examples then. On the first couple, we're actually given the pictures, so that will be the most difficult part when we're not given the picture. If you look at this one, it says an angle of elevation. So what I always say is let's start with the angle. You're looking out and you're looking up. So there's that 32-degree angle. They give us this distance is 1,000. They want us to find the line of sight. That means from here to there is the distance I'm looking for. Now we're back to SOHCAHTOA and we're labeling our sides with O's and A's and H's. So the first thing I notice is that X is the hypotenuse. This 1,000 is the adjacent. The only trig function that involves AH would be cosine. So cosine of 32 degrees is 1,000 over X. I'm going to set this up as a proportion and cross multiply. We're trying to get X by itself, so that means we're going to divide by the cosine of 32. And we mentioned yesterday in class, anytime that variable is in the denominator is that case that you're going to divide. So 1,000 divided by cosine of 32, and we get 1,179.2. This is 8. Let's go down and look at number 6 again. I'm just kind of going from, I would say, easy to more difficult. I'm picking 6 because, again, I've been given a picture. I have an angle. Ultimately, I'm looking for the height of the building. So we've got opposite. We have adjacent. OA, the only trig function we can use is tangent. multiplying by 200 or cross multiplying, we get x equals 200 tangent of 35 degrees. And we end up with 140.0. Now, here's the last little glitch though. From here to here is 140. And this guy is 5 feet off the ground, so that means this is 140, this is 5. I need to add on that 5. We end up with 145 feet. Let's go ahead and go up to number 5. It says we have a ladder leaning against a building. So I'm going to draw that building. We've got a ladder. It tells us the ladder is 25 feet. It says the base of the ladder is 13.5 feet from the building. And in this case, we're looking for that angle. So we're looking for this angle in there. Again, first thing we'll do is focus on the SOHCAHTOA and label our O's and A's and H's. If this is my angle that I'm looking for, this would be the adjacent side. This would be hypotenuse. The only trig function that involves AH is cosine. This is that case that we talked about yesterday. Anytime you are looking for the angle, we're going to use inverse. So we're looking for that angle that has this ratio. That means to find that we are doing inverse cosine of 13.5 divided by 25. It says angle, I'm going to round that to the nearest angle, and I get 57 degrees. Let's go to number 4. It says we have a 2-degree descent. So if you can imagine, not a very good picture, but here's my plane. Here's that 2 degrees that we're coming down. It says it's 3,500 feet above the ground. That means this is 3,500, so in my triangle, this opposite side is 3,500. They want to know how many miles from the airport is the airplane when it starts its descent, so they're looking for this distance right here. Got opposite and we have hypotenuse. OH would be sine. So sine of 2 degrees. Anytime that x is in the denominator, you're going to divide. If you can't see that, you're going to cross multiply. And to get x by itself, we would have to divide by the sine of 2 degrees. And end up with, this is in feet, 10,000 or 100,000, 288. If we wanted to convert it to miles, we would divide by 5,280 feet, because that's how many feet are in a mile, and we end up with approximately 19 miles. Okay, last one is kind of the flip of what we were doing. This one is climbing at an angle, so that would imply angle of elevation. So we're looking out, we're looking up. This is 11 degrees. It has an altitude of 400 feet. So that would be the distance off the ground here, and we want to find the ground distance, so that means we're looking for this distance right here. Opposite over adjacent would be tangent. So tangent of 11, 400 over x. Again, this is the case where we divide 400 divided by the tangent of 11. And we get 2,057 tonight you're going to do the best you can on that Math Excel. There will be some review, which you should be fine with, and then there will be some including this angle of elevation and depression, and you won't get a chance to